This section will discuss the factors affecting the rates of reaction. So what are the things that can increase or decrease the rate of a reaction? So in order for, or when a chemical reaction occurs, bonds are broken, bonds of the reactants are broken, new bonds, those are the products, are formed. And molecules can only react, reactants can only react if they collide with each other. And those collisions must include not only the correct orientation of reactants, but also enough energy, remember that minimum input of energy, to cause both bond breakage and then new bond formation. So we have this reaction here that we see. Here's the two reactants before the collision. They collide with correct orientation. And then after the collision, we have two new products. There are several factors that can affect the rate of a reaction, and they are as follows: the concentration of the reactants, the physical state of the reactants, the surface area of the reactants, the presence of a catalyst, and then finally the temperature at which the reaction occurs. The first thing that can affect the rate of a reaction is the concentration of the reactants. As the concentration, or in some cases the pressure of the reactants increases, so does the likelihood that the reactant molecules will collide. Here's an example of the flame of a Bunsen burner. So over here we see a very orange flame, okay? As more air is mixed with the natural gas via this air hole that the Bunsen burner has, we see the progression of what happens to the flame as more air is mixed with the natural gas, and so we have an increase in the concentration of the air to natural gas. The rate of combustion will increase, and we see that through the flame getting more blue in color. So this blue is a very fast, much faster reaction rate as the concentration of the reactants are increased. Also, we know that this is a much hotter burning flame. So as the concentration increases, so does the rate of the reaction. The physical state of the reactants can also affect the rate of reaction. In order to react, molecules must come in contact with each other. The more homogeneous the mixture of reactants, the faster the molecules can react. So a homogeneous reaction in which the reactants are in the same phase, so all solid, all liquid, all aqueous, or all gas, is a homogeneous reaction. And so the more homogeneous, the faster the rate of reaction. Surface area can also affect the rate of a reaction. When more surface area of a reactant is exposed, a reaction will occur faster. A steel bar will not ignite if exposed to a flame. In contrast, a steel wool pad will burn and ignite quickly. So I'm going to show you a video of that and explain what's happening.
Warning: this experiment involves flammable materials and smoke. This should be done outside or in a fume hood with basic fire safety rules. Greetings, fellow nerds. Let's do some really basic chemistry again. I have here some steel wool. It doesn't look like it, but it's actually quite reactive with air. To see this, first fluff it up a bit to give it more air between the voids. Now simply set on fire. As you can see, you get this nice light show of burning iron. What's happening is the iron is reacting with the air to form iron oxide. This happens with almost all iron, but steel wool is more spectacular because the small strands and high surface area let it heat up to the point that the reaction is self-sustaining and burns through the wool. Let's try that again. Be careful when doing this, as the wool will throw off sparks that might set nearby things on fire. You have to fluff it up a bit, because if you use compacted steel wool, the air can't get in and oxidize the iron. Now I'm going to go a step further and use the potassium chlorate we made from bleach in a previous video. Mixing equal masses of iron to potassium chloride will produce a very vigorous reaction, since we're providing oxygen directly in a more concentrated form. And that was burning steel wool. Thanks for watching. Please subscribe, like.
So for the steel wool, you could see that the more surface area that was exposed, the much more quickly the steel wool will ignite and burn.